Hi, ready for more differentiation? Of course you are. Of course you are. What a silly question. Now, if you've not seen my other video, I suggest you check it out, okay? Because I explain why when you differentiate sin x, you get cosine x, and why when you differentiate cosine x, you get negative sin x, okay? If you don't want to watch it, that's fine, but these are just two results you have to remember, okay? But there's an explanation, but that's on a previous YouTube video, okay? So you've got that. Differential of sin x is cosine x, and the derivative of cosine x is negative sin x. Once you're ready with that, we're good to go. And I'll just take you through some examples, all right? So we've seen this one. I'm just going to give you a reminder. Notice the way I've worded this. It says differentiate the following. WRT means with respect to x. So differentiating y with respect to x, you get dy dx. And I've said that's cosine x. So here, what do you reckon that's going to be? Now, if you want, you just pause the video and have a go at these, and then unpause it when you feel you're ready. Okay, but I'm just going to keep on going. All right. So when we differentiate sine 2x, let's forget about 3 for the moment. When we differentiate sine 2x, we're going to get cosine something. Okay. Now the angle is always going to stay the same. All right. I hope you understand that. Remember, with trigonometry, we take the sine of an angle. So when we differentiate sine x, whatever this angle is there, is exactly the same there. So the angle is going to stay the same. So it's going to be something to do with cosine 2x. Differentiate sine, you get cosine. So differentiate sine 2x, you get cosine 2x, okay? Now, the coefficient of that, what do you think it's going to be? 3? Well, let's just pause and think about the chain rule. Remember the chain rule? So the chain rule was if we just say that u is going to be 2x, and when we differentiate that, we'll get du dx is equal to 2. Okay? And in terms of y, then we'll have y is equal to 3 sine u. See how that works? Just look up chain rule if you want. I've got videos on pretty much everything to do with differentiation up to this point, so you can always check them out if you need a recap on the chain rule, product rule, quotient rule. Okay? But I'm just going to keep on going. So dy du is going to be 3 cosine u, and the chain rule is you do dy du times du dx. So it's going to be 2 times 3 cosine u. So you get 2 times 2, which is 6, and remember cosine u is going to be cosine 2x. So 6 cosine 2x. I'm hoping you're good with that, because you need to be able to do this in your head. Okay. The quick way of looking at it is, as I've said, you differentiate sine 2x to get cosine 2x, and then you differentiate this bit here. Imagine that is like in brackets. You differentiate what's in the brackets to get 2 and multiply it by the 3. Let's have a go at this one, just to make sure you're happy with that. So we're going to do this one just by inspection, as I like to call it, because you just look at it and see what the answer is and write it down. So when we differentiate sine, we get cosine. The bracketed bit will stay the same because that represents the angle. So the angle is unchanged. So it's going to be cosine 7x plus 1. Now, using what we call the chain rule, we differentiate what's in the brackets with respect to x. We get 7. And then we multiply it. So we get 7 cosine 7x plus 1. If you're not happy with that, just do the question, but this time let u equal 7x plus 1. And you'll see that you get 7 cosine 7x plus 1. Good with that? I hope so. Because I could do these a bit more quickly as we go on. So as a reminder, when we differentiate cosine x, we get negative, okay, sine x. Don't forget the negative, because that's quite costly if you do that every single time, forget the negative sine x. So here, when we have y is equal to negative cosine 4x, remember when we differentiate cosine, we get negative, so the negatives are going to cancel, okay? So that's going to be sine 4x, remember the angle remains unchanged, but the 4 is the coefficient. I'm hoping you're happy with why that is. If you're not, then just a reminder, differentiate the 4x, you get 4. Okay, you've always got to differentiate this little bit here and multiply, so you get 4 times sine 4x. This one here, cos squared x, okay? That's a really important one, okay, because it's quite common that you have to differentiate a square trigonometric term, okay? Now, it may be easier, let's just write it up here, it may be easier for you if you think of it like this. Remember, cos squared x literally means that. It's the cosine of x squared. Okay, so you work out cosine of the angle and then you square it, okay? Maybe easier to think of it like that. Now, in terms of the chain rule, what you're going to do is you're going to bring the power down. So you've got something squared. So you bring the power down, normals of a differentiation, and then you're going to have cosine x, because you decrease the power by 1. So cosine x to the power of 1, which is cos x, and then we differentiate what's inside the brackets. Okay? So differentiate what's inside the brackets, you get negative sine x. Okay? So I'm going to write it there, negative sine x. And I'm just going to write it a bit more neatly underneath. So it's going to be negative 2 sine x cos x. And just write down the work in terms of the chain rule. Okay, so in terms of the chain rule, what we're doing is we're going to say u is equal to cos x, and this way you see we get y is equal to u squared. Okay, now can you see what's going on? If we differentiate dy du, we get 2u. If we differentiate du dx, we're going to get negative sine x, then multiply them together, that times that for the chain rule. So negative sine x times 2u, so negative 2 sine x cos x. Okay, let's just do another one, okay, before we actually move on. I want to just get rid of, in fact, I'm just going to clear the screen, okay. There we go. Oops, done. Let's just do another one. What about if we have y equals cos cubed x? Maybe just try that one, see it all. Again, it might be easier if you just write it like this, just for the time being, until you're more comfortable with how to do these. And what I'm going to do is I'm going to show you the method of writing just the answer with no working, because that's really what you need to be able to be looking towards doing in year 13 maths. So bring the power down, so you have 3, decrease the power by 1, so it'll be squared, so it'll be 3 cos squared x. See how quick and simple that was, and how I've written it as that. Cos squared x, and then you differentiate this inside the brackets, you get negative sine x. So you could just write down the answer like this. Okay, let's do another one, but this time let's do it in terms of sine. So sine to the power of 5x. Okay, this time we're going to do it without writing like this, but it is the same as sine x in brackets to the power of 5. Okay, when we differentiate that, bring the power down to get 5 sine to the power of 4x, because you decrease the power by 1, and then you differentiate the sine x and you get cosine x. There it is. Okay, I'm hoping you're happy with that. If not, let me just one more time take you through how we set it up using the chain rule. Using the chain rule, I've got a different colour now just to highlight it. Okay, we would say that u is sine x, because that way you see y is equal to u to the power of 5. Do you see how that works? Okay, u to the power of 5 sine to the power of 5 x. Then we'd have du dx is equal to cosine x, and we have dy dx is equal to 5u to the power of 4. Now, can you just see why I'm presenting it like this? You're decreasing the power by 1, you bring the power to the front. That's why initially I wrote down this bit, you see. See, that bit is the same as this here, okay, the 5u to the power of 4. And we're always differentiating the sine x, because it's effectively sine x to the power of 5, isn't it? You let u equals sine x, so du dx is cos x. Okay. Now let's go back to generalisation, just by here, for you to make a note of, if you wish. Let's just change the colour again. So what if we have y equals sine to the power of n x? I'm sorry that you've got n there and n there, it's just that n is the letter we tend to use. Okay, remember x to the power of n with the differentiation rules. Okay, we tend to use n to represent a value. Doesn't have to be an integer. Okay, it could be a rational value if you wish. Okay, dy dx, what do you think that's going to be? So you bring the power down, well, just replace 5 with n. Okay, u to the power of n. So bring the power down, you have n sine to the power of, and then decrease the power by 1, n minus 1. So the reason we use integers more often is because it's more convenient. No one really wants to do irrational values, subtract 1, do they? Okay, it's a bit awkward. So it's kept nice and simple, at least in the A-level exam. And then we differentiate the sine x, you get cos x. So there's a general rule for you. And while I'm at it, why not write down a general rule for cosine? So cosine to the power of n x, again, where n is any number except 0, because it's trivial, obviously. to the power of 0. That's quite a trivial one. So, yeah. And when n is 1, again, it's trivial case. We know how to differentiate sin x and cosine x now. So that'll be n cosine to the power of n minus 1 x. Differentiate the cosine x, we get negative sin x. So it'll be negative that times by sine x. Okay, and if you want, you can just write down that as a generalization. Okay, and before we go into the next bit, just remember you have to do this backwards as well when we get into integration. That's a lot of fun, isn't it? Okay, you have to know that when you integrate this, you get that. Okay, but that'll be another video. Okay, but moving on. Differentiate this one. I want you to do it. Pause the video, have a go at it. Okay. You done that? Maybe you're after a little bit of assistance, a bit of a hint. My hint to you is to write it like this. Tan x is the same as sin x over cos x. And then try and differentiate it. Need another hint? Use the quotient rule. Yes, this question is really about using the quotient rule. Okay. Why? Because it's set out as a fraction, u over v. So we'll let u equal sin x and we'll let v equal cos x. Maybe if you didn't get that far, you pause the video now. Give yourself another go at it. Okay. Or if you're watching this while travelling on a bus or a train somewhere or in a car, try and do it in your head. Try and do it in your head. Right. So du dx, that's going to be equal to cos x. dv dx, that's going to be equal to negative sin x. Remember the quotient rule? Whoops, what did I write that for? Beg pardon. Strike that. Write it as y. I've not differentiated at this point. I was impatient for the differentiation. Okay, I wanted to write down dy dx straight away because it's in my head, and it should be in your head once I've given you the answer. Okay, because this is a result that you've got to be able to memorise and actually derive as well. Okay, do you like the hint, the lovely bit of play on words there? Yeah, we're doing differentiation, deriving, and you've got to be able to derive this result. I enjoyed that little moment. Okay. Sometimes I live for those moments during my lessons. Okay, I live for the time when I can just do a pun, and if no one laughs, I'm laughing inside. Okay. It's nice when people laugh with me, even if they're just being polite. Okay. But most of the time, students are kind of enjoying it as well because these little moments, they kind of make the lessons more interesting. I find. Anyway, I've gone off on a tangent there. Oh, I did it again. Notice that? Yes. Okay, of course you did. Yeah. That's not normal. Oh, no, that's another lesson. Okay, that's normal and tangents. Okay, I'm going to stop now and get on with this. Where was I? Quotient rule. So remember, it's v du dx first. So cos x times cos x, which is cos squared x. Subtract u dv dx. So it's going to be subtracting a negative in it. So it's going to be plus this times this. It's going to be plus sine squared x. And isn't it always lovely when we see cos squared x plus sine squared x? Isn't that always lovely? You should think it's lovely. All over v squared, which is cos squared x. Okay. The reason it is lovely is because that is just 1, of course. Of course it's 1, you knew that. So you've got 1 over cos squared x. But we prefer to write the answer as sec squared x. Okay. So the derivative of tan x is sec squared x. Okay. As a result, you need to memorise, and as I said, you need to be able to show that or prove that this is not a formal proof. Okay, so maybe just to show that using the quotient rule that tan x is equal to this. Now, formal proofs normally require some sort of differentiation from first principles or something like that. Right, good to go. I hope so. Let's just do these then. So remember, the general result is that we differentiate tan x, you get sec squared x. So what do you think this one will be? Again, pause the video if you want to try and think about it. Here we go, dy dx. Well, the answer is clearly going to be sec squared 3x times something. Okay. The reason is when you differentiate tan, you get sec squared. Whatever the angle is, it stays the same. So the angle is 3x. So it's going to be sec squared 3x. Using the chain rule, you differentiate 3x to get 3. So your answer is 3 sec squared 3x. Okay, nice and simple. Right, this one here. So, going on from what we had before, I've already done sine to the power of 5x, cosine to the power of nx, okay? So this one here, same again, bring the power down. So 5, and then you have tan to the power of 4x, Okay, so notice the similarities between what we did before and this one here. Then you differentiate the tan x, which is sec squared x, of course. That's it. Done. Okay, maybe I'll give you a more general result that you can write down in your notes. So when you do tan to the power of n x dy dx is going to be equal to n tan to the n minus 1x. So that's bringing the power down, decreasing the power by 1. Then differentiate the tan x, you get sec squared x. Okay, nice and simple. These are simple once you get into them. Okay, and you need to find them simple because you need to be able to differentiate these simply when you're using quotient rule and product rule in some of the slightly harder, more challenging questions. Right, well, I'm hoping you found that useful. I'm hoping that there's something in it for you. And if you're just watching for the fun, well, I hope my just odd drop-ins of the puns made it more entertaining for you. Okay, thanks for watching, and I'll see you again.